So please ask other students to join so that we can start the second session of the class. Right. I have four students already who have joined. Okay. Let us start. In any case, I will be uploading the video to the YouTube and I'll share the link with you. So let me start without wasting much time. I'll continue. Okay. So now we are going to discuss about the resistance welding process, wherein this welding process is about the here your mechanical heat or heat is generated due to the electric current. And what exactly happens here, the workpiece material acts as a resistance, okay, towards the flow of current. And yes, are you able to see, all of you, the slide? Right, fine. Okay, so okay, this one. All right. So now the resistance welding process is a process wherein the heat is generated due to the resistance heating. There is H equals to I square RT, and the resistance is offered by the workpiece material. The maximum thickness that can be welded is up to 12 mm. Okay, so mostly in the resistance welding process, sheets are welded. Okay, we cannot weld plates as in your manual metal arc welding process, right? So if we come to the definition of the resistance welding, it is defined as the fusion welding process, and in which the coalescence means the uh, heating and joining of metal takes place at the flaying surfaces by the heat generated at the joint by the resistance of the work towards the flow of the electricity. So the workpiece uh, applies a resistance, or it acts as a resistance towards the flow of electricity through the electrodes, and the material gets heated and it sticks to each other due to that amount of heat. And there is a reason why the sticking or that joining takes place, because a mechanical force is applied after the current is passed through the workpiece, right? So the force is applied before, during, and after the application of the current to prevent arcing. So there is no arc which is generated in case of resistance welding process. In case of, if you remember, arc welding process, there is a gap which is maintained between the electrode and the workpiece, and due to that gap there is a ionization take place between the gap, and the arc is generated. And here the arc is not recommended to be generated, because there is a high current which passes, and the to welding takes place due to the mechanical pressure and the resistance offered by the workpiece through on the path of flow of current, right? So the melting occurs at the flaying surface during the welding process. Now let us see the working principle. So the heat is generated by passing current through an electric resistance. So the amount of heat produced is depend on the resistivity of the material. These are the bullet points. Okay, resistivity of the material, surface conditions, and current supplied, and the time. Okay, so resistivity of the material is the R. Okay, depends upon the resistance that is offered by the material. So different types of materials offer different values of resistance. Okay, the surface condition, again the surface condition, if it is not very good, in that case the resistance offered will be much more than the smoother surfaces. Current supplied, definitely if the current supplied is high, and if in case you can see the equation, that is H equals to I square RT. I already told you how this relation comes out, right? That H equal means you can find out using the power and sorry, current and voltage. Okay, so from that relation you can find out this I square RT relation. It was in your class 10 physics book. And the current supplied is squared, so a huge amount of current is supplied, and the entire current whatever is being supplied is utilized, and the square of that current, you can understand the amount of heat that will be generated. And definitely it also depends on the time. This T is not temperature, this T is the time by which we apply the pressure or the allow the current to pass through the metal, right? Types of resistance welding: spot welding, seam welding, projection welding, and flash butt welding. So I'll discuss spot welding in details. So coming to the spot welding process, simplest type of resistance welding is a spot welding. What exactly happens here? Two copper electrodes with anvil faces. Anvil faces means pointed faces, not very much pointed as in pencil pointed, however slightly tapered at the end, okay, slightly pointed at the end, and we have a circular end. So the you can see here, if I mention this, this is the area of contact at both the electrode ends. So two overlapping metals, these are the workpieces, this is the workpiece, and the workpiece, two workpiece or sheet metals are overlapped with each other, and the electrodes are placed in this manner, and the mechanical pressure is applied. During that mechanical pressure, electric current is passed through, and high current, as I already told you, high current is passed, and the nugget is created. So the what is the nugget? Nugget is the circular molten, or we can say the weld, which is created due to the melting of these two metals at these two portions. Okay, at the faying surface. Okay, so due to the pressure, what happens? There is no arc which is generated. The high current flows in the suppose, for example, this is the direction of the flow of current, right? So the current is flowing and it's moving out from this direction. So the entire circuit is completed. So we can say there is a short circuit which is taking place, and the amount of pressure or amount of time we hold this two electrodes together, the amount of heat will be generated, much more heat will be generated here. Okay, and we will have a certain amount of melting which will be taking place here, and it will form in the create in the form of a nugget, right? So this will be in the form of a nugget here, right? And these two metals will get welded with each other. All right, so I believe it is this is clear. Now the process involves applying pressure and heat to the weld area using the shaped alloy copper electrodes, which convey an electrical current through the weld pieces of maximum 12 mm thick. Maximum thickness can be 12 millimeter, right? That can be welded. So the material melts, fusing the parts together, at which the point the current is turned off. Pressure from the electrodes is maintained at the, and the molten nugget solidifies to form the joint. So you can see here, this is the support which is given. So I'll again use the tools here. So this is the support which is given here by the lower part of the electrode. The two metals are placed in overlapping nature. This electrode is moved in the downward direction and a force is applied. So mechanical force is applied from the top, and as you can see, there's a DC supply plus minus. So DC power supply is used. So the current flows in this direction, and there is a nugget formation which takes place here. There's a nugget formation which takes place here, and this nugget is the joint between the two metal sheets. So pressure is kept even if the current is withdrawn, and till that material gets joined with each other, the pressure is maintained, and after which the pressure is being withdrawn. Okay, so this is withdrawn. Again, in the next part of the material, again this process is followed. Okay, so you can say the first step is hold, then the current is passed, then squeeze, then remove the or leave the material. Okay, there are 4 steps in which the process is completed, right? Now what are the materials which are appropriate for spot welding process? So due to its lower thermal conductivity and high electrical resistance, the material which has high electrical conductivity, we won't be able to perform the resistance welding on this on the material, because in that case the current will pass through the uh, workpiece, and the workpiece will not act as a resistance. So if you are using some aluminum material or some copper material as a workpiece, you will not be able to weld it using this spot welding process properly. So we have to use a material, or the workpiece material should be of lower thermal conductivity and higher electrical resistance. Okay, that doesn't mean we will be able to weld something which is non-conductive in nature. That is also not what I'm trying to say. Okay, so steel is comparatively easy to spot weld, with low carbon steel being most suited for spot welding. However, high carbon steel carbon equivalence, if it is higher than 0.4% weight, you have studied the iron carbon equilibrium diagram. So any steel which is lower than 0.4, we can call it low carbon steel or medium carbon steel. Okay, and high carbon steel are prone to poor fracture toughness or cracking in welds, as they tend to form hard and brittle microstructure, right? So low carbon steels are preferred in case of spot welding process. Now electrodes that can be used can be copper. Why copper can be used? Because copper is very much conductive in nature. Okay, we can use copper and tungsten, we can use copper and chromium. Copper and aluminum can also be used along with like, because all the materials are very much conductive in nature, right? So you will see mostly copper is used, tungsten and chromium. Okay, they are used in few special cases. Okay, mostly you will see copper is being used, and also the reason is that copper is easily available at a cheap rate. Okay, where this spot welding is used, or rather what is the application of this spot welding? You, in case people have some of the students who have worked in the or have taken up projects in automobile manufacturing, they have an idea of what spot welding, wherein the car bodies are spot welded together. So this has a wide application in automotive industry, aerospace industry, rails, white goods, metal furniture, electronics, medical, building and construction. Okay, now given the ease with which the spot welding can be automated, when combined with robots and manipulation system, it is most common joining process in high volume manufacturing lines. So you will see, in case you see some videos which are available online regarding manufacturing lines of automobiles or assembly lines of automobiles, you will see a lot of spot welding guns which may be used by robots, or they are in the flexible manufacturing system. Okay, they are a part of the manufacturing system wherein we can use for joining steel, and like steel cars are made, uh, so the sheets are overlapped with each other and they are joined together. Okay, however, this spot welding process is similar to that of the stitching process. Okay, wherein there are gaps between the stitches because it is not continuous in nature. So this spot welding process, if some kind of means leakage takes place, okay, the spot welding process will not be sufficient for the for or to prevent the leakage. Okay, so in that case, what can be done? This spot welding, if you perform the continuous spot welding, that will be your seam welding process, right? That is a seam welding process. Let me see. I'll try to grab some video wherein I can show you some spot welding process. Let me check if I can. I was trying to get some video wherein uh, just give me some time. Okay. So the video that I'll be showing you is an animated video. Okay, and I have downloaded this video from the YouTube, and I'll share this video with you. Spot welding animation video, in which you will be able to see. So this is how a spot welding machine looks like, right? So this is a rocker arm which moves this upper electrode up and down. Okay, so these are the electrodes. You can see the structure of the electrode, how they look like. Okay, so this is the metal work pieces. So metal pieces are placed between the copper electrodes and current is passed through the electrodes. So as they come in contact with each other through the metal offers a resistance, and this kind of weld is formed, right? So the pieces are heated at their contact by electrical resistance. So as you can see, this is the way, right? The mechanical pressure is created. Okay, it can be created by mechanical pressure or maybe by some hydraulic pressure. So this is the application of spot welding. Okay, so let me get back to the slide. Now, I believe you got an idea of how spot welding works. Okay, that is two metal pieces or in the form of sheets are placed between the electrodes, and electrodes here, they create a spot. Okay, and that spot is created due to the resistance offered by the workpiece in the passage of the current, and the material gets heated up, the mechanical pressure is applied on the metals, and the welding takes place. There's a nugget formation takes place. Now let us come to the seam welding process. This process is also known as continuous spot welding. Now, in continuous spot welding, what exactly happens is a roller type of electrode is used, and the continuous weld is created. Okay, the time and movement of the electrode is controlled to weld, overlap, and now what happens if you remember that in case you are trying to manufacture some fuel tank of your automobile which you manufacture in your workshop, so you will not definitely allow any kind of leaks that will happen or that will take place in your uh, uh, fuel tank. So in order to create airtight joints, so spot welding, if you like, suppose your as I told you, spot welding is similar to that of creating stitches or rather stapling. If you are using a stapler and you're stapling two sheets of paper together, okay, so the staples will be at some certain gaps. However, if you properly staple it throughout, okay, and make sure that there is no gap between the two sheets of paper, then you can make sure that nothing will pass through. Okay, but here it is like welding definitely is not similar to that of the stapling, because in welding there is no gap at all. Okay, so if you create a weld in this manner, okay, by two roller kind of, in the previous case in spot welding we have seen the electrodes are in the form of some cylindrical rods. However, here we use some rollers, and these rollers move in such a manner, uh, keeping the workpiece as the workpiece passes between the rollers, the electrical current which pass through the roller, okay, or first from the roller, it passes through the workpiece acts as the resistance towards the flow of current from the top lower roller to the bottom roller, and along with that mechanical pressure is also applied. So this is a continuous spot welding which is called as seam welding, right? So the electrode is in the form of a roller or disc, we can say, and the electrodes are connected to the power source, and the weld is formed. Okay, so you can see there are other diagrams of seam welding. So these are two sheet metals which are needed to be welded together. So this is the electrode wheel. These are the overlapping weld nuggets. Okay, so the nuggets are formed. Okay, however, this is called resistance seam welding, or we can say roll spot welding. However, in continuous seam welding, okay, this kind of thing which you can see is like I'll show you here. So this kind of, it will not be a nugget formation, but it will be a continuous line. In this case, in the previous case, in this case, see, this is, there is a gap, so there can be leakage through these places, right? Now, in case you are trying to manufacture any kind of fuel tank, you will not definitely like this kind of gaps. So it is beneficial that you will have a continuous resistance seam welding in this manner, right? So the pressure is applied continuously, and that is before, after the welding, before, during, and after the welding is being prepared. So this is a oh, you can say this is a application of seam welding. So there is some thing which is being manufactured, or it is being created, some welding is created. Okay, I'll try to show you a video of the seam welding as well. Okay. Right. So this is a seam welding which is taking place, and this video again I have taken from YouTube. See, here the welding is taking place here, and there is the wheel is not removed repeatedly, right? So when the electric current is passed, high heat is generated between the workpiece. So these are the applications of resistance seam welding. Okay, any kind of cans, any kind of containers where it has to be made leak proof, any kind of heat exchangers, okay, motor cases, nuclear components, okay. So these are seam welded. Pressure vessels also, okay.
Boilers.
These are the, yes.
Boilers, sir.
No, boilers we don't use seam welding. Okay, the reason is boilers we don't use seam welding. The reason is because wait, I have to stop this. Okay, right. Boilers we do not go for seam welding because the shell thickness of the boiler is very much higher. Okay, because the amount of heat which is contained inside the boiler, that amount of heat is very high, right? So we
Okay.
don't recommend seam welding for boilers. However, in case of boilers we can go for submerged arc welding process, okay, and other welding process wherein leak proof process can be taken place, because the sheet thickness in case of the, or the shell, outer shell thickness is much more as compared to other like heat exchangers or something, right?
Okay, sir.
Okay, so let me get back to the slide, right? Next is your projection welding process. In the projection welding process, there is some projection which is done, as you can see in the diagram. Okay, so there is some projection here. So this projection creates a resistance as the current is passed. So again I'll show the current which is passing through. Suppose this is the current which is passing through. This projection will create the resistance at these places. So as in the previous case also I told you that in case the surface is not very smooth, what will happen? The resistance will increase. If there is some kind of surface irregularities, there will be more resistance at those places, right? So here these irregularities are made purposely in order to make sure that the resistance welding takes place, and the projections gets converted into molten state, and they get joined with each other. Okay, so we can call it a dimple is produced on the workpiece using flat electrode. So electrode again here is not similar to that of the spot welding. The end of the electrode is flattened, right? And the sheet, one of the sheet is acting as a support, another sheet has some kind of dimples or projections on it. So those projections acts as the resistance, and those projections gets converted into molten metal, and it joins with the uh, metal or the sheet which is beneath that, right? This is all about projection welding. We have around 10 more minutes left. I'll quickly wrap up this and then I'll go for questions. last is your flash butt welding. So as you can see here, the flash butt welding is again a resistance welding process, and here there is some flash which is created between the two electrodes. One electrode is fixed and other electrode is movable. So in this, what happens, the energy is transferred primarily by the resistance heat from the parts themselves. So the current is passed through the two electrodes. The components are positioned end to end in the full joint area, and uh, these are used to weld tubes and rods. So suppose these are the tubes which are required to be joined. So this is the electrode. I'll show you here. This portion is the electrode, and your this portion is the electrode, and this portion is the workpiece, right? So this workpiece, they are connected together. They act as a since the current is passing through this, uh, the gap and the gap is reduced, and there's a flash that takes place due to the resistances between these two material. Okay, and the current of high pulse around, we can say around 1 lakh ampere is passed through. Okay, and in maximum, you can say that the amount of current here is uh, means around 1 lakh ampere, maximum current we can use. Okay, very high ampere is 1 lakh or 1 lakh 50,000 ampere, or we can, that kind of that level of current is passed through, right? Kilo ampere, 150 kilo ampere, that is the range. Okay, maximum, and the voltage is very less. Okay, so one is moved and another is fixed. So there is a weld formation between these two parts, and please be rest assured that these two portions are hollow. There is this, not, it can be hollow or it can be normally it can be solid as well, but normally for joining pipes, we can, pipes or rods, we can use this kind of structure, right? Okay, so this was the last slide, and I will end the meeting. Before that, what I'll do is I'll quickly unmute you people, so that I'll stop the share of the slide. I'll unmute all of you, so that in case you have any questions regarding the processes that was discussed today, you can ask, I can answer. Yes,
Sir, I have a question.
yes, please.
Sir, how we are just applying pressure in the case of seam welding?
Okay.
Because we have the disc as
In case of the
electrode.
seam welding, what happens? The roller or the disc, which is at the or which is below the workpiece, is fixed. It remains fixed, and on top of that roller, you are placing the workpiece. Okay, and the upper disc is creating the pressure. Along with that, you're applying the rotational force. Okay, so if you remember how you take out the sugarcane juice from the sugarcane, right? So you apply pressure
Yes,
as well
sir.
as you rotate. So that is the idea. Okay, so, and you keep the pressure on till the material is between the two discs, right? That pressure
But
is
sir,
maintained. So for a fixed
but sir, the
set of
disc will be
rollers,
deformed.
sorry, no,
The
there will
disc
be no
will be
deformation,
deformed.
because that is what I'm trying to say, that for a fixed set of rollers, we have to make sure that the thickness of the material has to be fixed. We cannot keep on changing the thickness, right? Normally, seam welding process, suppose I buy a seam welding machine today, I have to use a specific thickness of material for that machine. So if I use a thicker material, what will happen? As you know the rolling process, it will be plastically deformed. Now, what will be plastically deformed depends again on the ductility of the material. Now, copper, if it is softer than the work material, or the electrode is softer than the work material, then the electrode will deform rather than the work material. Right? So that is not recommended. The gap is maintained in such a way that there is a certain amount of pressure which is applied, which will not deform the workpiece or the electrode, right? And it will apply a constant pressure on the workpiece. Right?
Yes,
Is it
sir.
clear?
Yes, sir.
Okay.
Yes, sir.
Any other doubt you have? Anyone else?
No, sir.
Okay, thank you. Please uh, enter your roll numbers here. Okay, so that I can get the attendance. And
So in the chat box.
I also have created a test for in IMCRP. You can take the test from 4 p.m. onwards, right? And I will request you to prepare well. Your mid-semester exam schedule is already up. Okay, so
Yes, sir.
please prepare well for the mid-semester exams, right? In case you have any doubt, you can contact me via WhatsApp. Okay, I'll get in touch with you, right?
Sir, the midterm will be of
Okay,
how
sir.
much marks?
Midterm will be of how much marks? It will be
Yes, sir.
30 questions. I'll update you about any kind of information. Okay, 30 questions per subject, right?
Okay,
And
sir.
Sir,
for any
MCQ.
kind of information regarding the marks and all, I'll update you later. Yes.
Okay, sir.
Okay, sir.
Okay. Thank you very much
Sir,
for attending
MCQ
the
টাইপের
class.
হবে?
Have a good day ahead. Thank you.
Yes,
Thank
sir.
you, sir.
Thank you, sir.
Thank you, sir.
স্যার সাবধানে থাকবেন।
You too. Thank you.
একদম স্যার।